stuff for this week yet?
I started doing the homework, and I didn't feel like it was too bad. Like some of them I had to do. I was just telling Antonio, like, it's easy if you can like keep track of things, but the minute like I start just writing random equations everywhere, and then I get lost.
Yeah. No, I'm the same. Especially when they throw in like the 3 variables, that's when it starts to get a little
get a little
tricky. So. Okay, coolios.
All right. So we don't have too many extension problems. I mean, there's a couple parts, but
yeah. Okay. So, does everyone have the extension problems pulled up?
Yeah, I do.
Okay. So, for the first one, so it says we have to solve the following 3 systems for the non-linear equations as a team. So the first one is y equals 3, or absolute value of 3x, and then y equals x squared plus 2. So the way you start off is you would just get one variable or substitute one equation in for the other, right?
Yeah. And wouldn't it be easier to substitute the absolute value of 3x into the other one?
Yeah, that's what I would say.
Wait, what was that?
So we're gonna substitute one of the equations into another one.
No, oh yeah, no. I didn't hear that last part that you said.
Oh, I said I
think
it would be easier to use the 3x and substitute it into the x squared plus 2, since we're already working with x's, versus trying to solve it for y.
I thought I heard the opposite. I was like, what? How is that easier?
Well, that's not
So do we just put in?
So we do 3x squared plus 2. So 9.
Well, if it was 3x squared, it would have to be y, right?
Yeah.
So we'd have to solve it for x first to put it into the x. Does that make sense?
Yeah.
So would you just divide by 3 and
Yeah.
then just have y over 3 equals x?
Mm-hmm.
Okay, so we have y y over 3 equals the absolute value of x. So that means that this is going to be positive, right?
Mm-hmm.
So then if we substitute that in, we get y equals y squared over 9 plus 2. And then we need to get we need to get the y squared onto the other side.
Should we get rid of the fraction by timesing everything by 9?
Yeah. So you'd both 9 to both sides, right?
Yeah.
So 9. So the 9s would cancel out, and you'd put that in. So then you get 9y equals y squared plus 18.
Yeah.
Okay, and then from there,
I think you want to get it on all the other side, and then we're gonna factor it.
Yeah. So minus the y squared, right?
Mm.
The other side.
I think it's easier to do y squared minus 9y plus 18.
Yeah, you're right. So it would be setting everything to 0. Is that what you're saying?
Yeah. Because then you can take those factors and put it into and solve for the different solutions that way.
Yeah. So then if you factor that out, you get y minus 6 and y minus 3, right?
Yeah.
Okay, so then we know one of them is going to be 6, and one of them is going to be, or positive 6 and positive 3. So then what we'd have to do is we'd have to plug them in for
the original. Then we do 3 divided by 3 equals x, and then 6 divided by 3 equals x.
Yes. So if we plug in the 6, first, we get x equals 2, right?
Mm-hmm.
Answers is going to be 2, 6. And if we plug in a 3, we get 1, right? So one of them is going to be 1, 3. And then we have to plug them into the other equation as well, correct?
Yeah.
Okay, so then if we plug 6 in again, we get, you have to subtract 2, which gets us 4. And then 4 equals x squared.
No, you only have to do it one time. The other one. I mean, it should be the same answers. So your set would be parentheses 1, 3, and then parentheses 2, 6, and then it would be negative 1, 3, and negative 2, 6.
Okay.
Because even though the absolute value usually is only the positive, remember like a few chapters back where you set up both and you had to do both positive and negatives equation?
Yeah, okay.
So then,
I remember. Because
why wouldn't
if you plug in -2 or -1 into the first equation, the absolute value, it's going to give you the +6 or the +3.
Okay.
Okay, that makes sense. Okay, so those 4.
Yeah, 4 plus
And let's see. So we had 2, 6, 1, 3, -2, 6, and -1, 3. Cool. Okay, did everybody follow that?
Yeah.
Okay, sweet. All right, so for the next one, we get, so x squared plus y squared equals 25. And then we have x squared over 18 plus over 32 equals 1.
I think we need to find the lowest common denominator on that one.
And then add them. Were you going to add them or?
Oh. I was, but.
If you find the least common denominator, don't you just have to add the top part? Just kind of put them together, and then like right there, how it's set up right now, it would just be x squared plus y squared over whatever the common factor is or denominator is.
Well, I think once we get them all in the lowest common denominator, then we can times the whole thing by that lowest common denominator. So yeah, you're right. We just have to figure out.
So it'd have to be, so the lowest common denominator.
Is there one?
Well, I don't know if this is something else. Couldn't you just, for the first one, couldn't you just take the square root of each variable and then solve for x or y? So if you took the square root of x squared and y squared and 25, you'd get x plus y equals 5.
Yeah, that's easier.
And then we just figure out, or then we just solve for which one we want.
I like solving for x.
It'd be x plus y equals 5, right? It'd be plus or minus 5, right?
Yes.
And then we want x, right?
Yeah.
Yeah.
Okay, so then we'd have x equals
5
plus or minus y. And then we need to plug that x into the other equation, correct?
Yes. And solve for y.
Then we get 5 minus y squared over 18 plus y squared over 32 equals 1. So if you factor that out, you get 25 minus 10y minus, or no, plus y squared, right?
Mm-hmm.
Over 18 equal, or plus y squared over 32 equals 1. So then from there, could we multiply by 18? Could we factor in 18 to both of these so it cancels out the 18 and then drops the other 1 to 1/2 and then the 1 to 18? So we get rid of,
Yeah, I think
or I guess that first one, right?
yeah, that one turned out.
Yeah, so if we multiply 18 by the whole thing to both sides, we factor in 18 over, so that cancels out the first 18s. And then it simplifies the second part to y squared over 2. So then what you're left with is the 25 minus 10y plus y squared plus y squared over 2 equals 18. And then you just add everything over. Or I guess you'd subtract the 25 over, right?
Yeah.
Minus 25 minus 25. So then you get negative 10y plus y squared plus y squared over 2 equals, what's 18 minus 25? Negative 7. Yeah, that's correct, right?
Yeah, and then could we times the whole thing by 2 again to get rid of the fraction again?
Yeah. So multiply by 2 to both sides. So then we get negative 20y plus 2y squared plus y squared equals negative 14. And then we could pull a y out of that whole left side, right?
So if we combine, it's 3y squared minus 20y plus 14. If we pull it all over the inside.
Oh, yeah, you're right. Wait, you said plus 4. Oh, yeah, 14. My bad. So did you just set the whole thing to 0? Is that what you did?
I feel like it. I don't know if this is true. Because the 20 is not divided by, or it can't take out 3 without getting a fraction back.
Yeah.
Or I guess 14 is that
It's
too.
Yeah, it's one of those weird factoring.
I hate those ones. Or I'll be right back, okay?
Okay.
Okay. So you don't think we can pull a y out of there, could we, Antonio, just from the left side?
I'm not sure. I'm trying to look. I'm trying to find. Do you know what page on the book it was? It's all this is on?
I don't remember. All I know is it's just chapter 8.
What chapter? Okay, I was trying to figure out which. Can't remember which chapter it was. I don't know why.
Okay. So you're saying instead of taking the 14 over, leaving it there and pulling out a y? Is that where you guys?
Yeah, but maybe that's like too complicated to do. Maybe we should have done it in the first place, where we should have multiplied the first equation by -1/18, and then got rid of the x's, the x squared part, and then added the y and the other part. Does that make sense?
Mm-hmm. So starting over again.
Yeah, let's try that. This one's going. So we're multiplying the whole top equation by -18, or -1/18.
Oh. Okay, I see what you're doing.
So you get negative.
Both instead of trying to get one, we're just using those two equations to cancel each other out.
Yeah, so like the addition, this.
Yeah. Okay, that makes sense.
We get -x² / 18 minus y² / 18 equals negative. What's 25 plus 8 or times 18? Times 25, that's 450, so -450. And then what we could do is we can actually change the y part to, we can do it, or how would you change that over?
We have to still find a common denominator, right? The least common denominator? Because we're adding, so they have to be.
I don't remember how to find these common denominators.
You have to find one that they both go into, but I'm not having very good luck, so. Oh, 96.
96?
Yeah. So
okay.
This one needs to go. Oh. Just kidding. Right, sorry. Please hold. I lied. I got too excited.
No worries.
Hmm.
Yeah.
I don't know, actually.
Yeah, because you can't, because like for the second one, you have to, if you're trying to find a common denominator, you wouldn't be able to, because you'd have to distribute to the 18 and the 32 at the same time.
Well, and if we did that, actually, if we got the least common denominator, since it's -y², it actually would cancel each other out. Right? No, just kidding. I'm all sorts of jokey today.
Let me see something. Oh goodness, I thought this was going to be so much easier, but
yeah.
I'm gonna look up in the textbook. Or if Antonio, do you see anything in the textbook?
No, I'm trying to do it a different way. I went back to do the last one. I'm trying to see if maybe I can find a different thing to do with it. Oh, dang it. Nope.
I mean, the only thing I would be able to like know right off the top of the right off the bat is x squared plus y squared equals 25. So I could figure out x and y. Like I can figure it out really easily.
So we can just do that and then plug that into the other. Would that be easier? Then you're not dealing with.
I'm trying to figure out here.
Because we could do it one by one, like taking the x. Because that would give us.
Maybe if we did like the first way that I was saying, but we don't take the square, like we just subtract y squared, and then just keep it in the radical form.
Okay.
So the original, so x squared plus y squared equals 25. So minus the y squared over, so you get x squared equals 25 minus y squared, and then take the square root of that whole thing. Then you get x equals the square root of 25 minus y squared. And then plug that in for
Minus
x
y.
minus y squared.
If you take the square root of it, wouldn't it get rid of that square?
No, since it's still, so it's 25 minus y. That's why you can't.
Oh, under the whole thing. Okay.
Yeah, sorry.
Sorry.
So then you plug in the x, then you get square root of 25 minus y squared over 18 plus y squared over 32 equals 1. And then you multiply 18 or factor 18 out to each side, so it cancels out the 18. And then simplifies the second y squared over 32 down to something. We'll have to figure that out. So then you get square root of 25 over y, or square root of 25 minus y squared plus, and then 18 over 32 brings, or reduces down to
Over 16.
9 over 16, you said?
Yeah, I don't think it can go further than that.
Okay, so 9 squared, 9y squared over 16 equals 18.
And then times, since there's no more on the other side, could you times by 16?
Yeah,
oh,
we could.
Solve the y 25 minus y squared. So,
Yeah, so it would just be on the outside of the square root, right? If we multiplied it by 16. Okay, so then, so 16 to both sides. So then we get 16 square root of 25 minus y squared plus 9y squared equals 18 plus, or 18 times 16, which is 288.
So or the fractions. So then can we just subtract the others? Oh.
So I think, oh shoot, So I think you can subtract either y squared to the other side and pull out like a common factor.
Okay.
So do you want to do the 9 squared just because it's easier than 9y squared?
Sorry, you're frozen. I didn't hear what you said.
Subtract the 9y squared to the other side.
So then we have 16 times square root 25 squared equals 288 minus 9y squared.
Yes. And then if we do 288 divided by 9, you could pull out, or so it reduces down to 32 outside of 9 minus y squared. So you get 16 square root of 25 minus y squared equals 9 outside of 32 minus y squared. And then
I think this is I don't know.
yeah, I feel like we're not doing
I
something.
think it's making it harder than it probably needs to be.
I'm gonna look on it.
Let's see if there's any light on it. Yeah, I don't see.
So if you look on page, what page is this? I can't see it that well. 563. If you look at the B example, there's one where it deals with fractions. I don't know if that's okay.
Let me pull it up. I don't know why they do like easier problems on like homework, and then when it comes to this kind of stuff, they like throw you something that's like crazy hard.
It's just like I can see for the first equation that it's going to be plus or minus 3 for either x or y, and then plus or minus 4 for either one either, because if you do this, if you square 3 and you square 4, you get 9 plus 16, which equals 25.
Oh. So, but you're just wondering how you find out algebraically?
Yeah.
Is that page 563?
Yeah. That's just one that is equivalent that I see. Just because it deals with fractions.
Mm-hmm. My computer is being slow. Or... Still thinking about it. Seriously.
Oh, goodness.
Should we just go to the next one and then come back to that one?
Yeah, I'm honestly over this.
Well, are you okay with that, Antonio?
Yeah.
Is that okay? If we don't know, I bet just because we do this, it's going to be on the test. But
Yeah. I mean, hopefully she explains it. Because, like, I don't like how she just, like the other one she kind of explained, like, with the answers, like, earlier in the semester, but in these ones, it's just, like, the answer.
yeah.
So, all right, let's go to the next one just to... Okay, so we have y equals 3 to the power of 2x plus 1. And then we have y equals 9 to the negative x power.
I don't remember the rules about exponents.
So,
Nope.
something like this.
It's negative. I think this is going to pull down into.
I think all this reminds me of is doing natural logs and stuff like that.
I think that's what it is. I think you have to do. It turns into log 9 of y equals negative x.
Well, what you could also do as well is if you change the 9 negative x to a base of 3. So it matches the other one, and then you just have both the equations equaling each other.
Yeah,
Does that make sense?
Mm-hmm.
So what you change the 9 negative x to is you have a base of 3, and then it's 2 times the negative x, because 3 squared equals 9. Does that make sense?
Yeah, that does.
So then you'd have both of them as a base of 3, and you could set them equal to each other. So then you have 2 times negative x, which is just negative 2x equals 2x plus 1.
Sorry, you said what was it before the 2x plus 1?
The negative 2x, because it's just 2 times negative x.
Oh, okay.
And then you add 2x over. So then you get 0 equals 4x plus 1, and then subtract the 1 to the other side. Then you get negative 1 equals 4x, then divide by 4. So then x equals 1/4.
Negative 1/4?
Yes. And then so now we just plug that back into the original equation. So the best one to do would be the first one. So if we solve the exponent first, we get y equals 3 to the 2 times negative 1/4 plus 1. Then you get y equals 3 to the negative 1/2 plus 1, which turns to be 3 to the 1/2, right?
Yeah, that sounds good.
Which 3 to the 1/2, that just turns into the square root, right?
Yep, that is right.
So then y is the square root of 3.
I don't think you can. I think it has to stay like that, right?
What was that?
So I think that would just be there's only one solution then. So negative 1/4 and then square root of 3.
Yeah. And if we check, yep, that's what it becomes. That one, I don't know why that one's easier than the other. We have to go back to natural log kind of stuff, but
Yeah, I'm glad you said the 3 because I forgot about doing that. That makes it a lot easier.
yeah, that was like the first thing that came to my head. All right, so the next one So this one, so the following problem is a bit more difficult because it involves fractions with a variable in the denominator. The problem has to be started for you. Discuss the method used and why it is a good method to use and finish the problem. They have 2 over x plus 3 over y equals 1/2, and then 4 over x plus 1 over y equals 2/3. So what they do is they multiply the first equation by -2. So that changes everything to -4 over x plus 6 over y equals -1. And then they keep the second one the same. And then they add the 2 equations because they both have common denominators in the bottom. So the -4 over x part cancels out.
Mhm.
So we're left with -5 over y equals -1/3. So now we just have to finish the problem from there, right? So we just have to figure out what y is.
Yeah.
So if we have -5 over y equals -1/3, so then so we multiply the y to the other side, correct?
Yeah, or we could times by each side by 1/5, because that would get rid of the 5 as well.
Oh yeah, -1/5, right?
Yeah, -1/5.
Okay, so those both cancel out, and then times the other side by -1/5. So then we get y 1 over y, correct?
No, I think it would be -1/3 times -1/5.
Well, I meant for the other side. Because we can't. So if we multiply by 1/5, the 5s cancel out. So we're stuck with 1 over y still, right?
Yes.
Okay, so 1 over y equals 1 over 15, correct?
Yeah.
And then multiply by y or
And then we can do the reciprocal, and I think it would change that to instead of, so right now how I have it is it's 1/15, and then I think if we do the reciprocal, then it's y equals 15.
you'd have to do the inverse though, right?
Yeah, that's what I meant.
So it would change both sides to negative though, right? So you have -y equals -15, and then just divide the -1 out, right?
Yeah, and then it would be y equals 15.
Okay, so then you get 15 as y. And if we plug that back into one of the originals, so which one do we want to plug it into first?
The one with the 1. The bottom one, the 4x.
Okay, so then we get 4 over x plus 1 over 15
Yeah.
equals 2/3. So then we would subtract the 1 over 15.
Should we subtract the 1/15 over the other side and then deal with the least common denominator on that side?
Yeah. Then we get 4x equals, so if we multiply 2/3 into 5, so we get the denominator as 15, it's 10 over 15 minus 1 over 15. So then,
9 over 15.
yeah, so 4x equals 9 over 15. And then if we multiply by 1/4, we get x by itself, right?
Yes.
So then we get, so 1 over x equals 9 over 60, right?
Yeah.
9 over 60, and that reduces down to 3 over 20, right?
Yeah. That's right.
And then if we take the inverses, so we get -x equals -20 over 3. And then divide by -1 to both sides. Then we get x equals 20 over 3, right?
That's right. And then your solutions, that would just be 20 over 3 and
15. So I guess if that one's still, I guess, couldn't we do this, couldn't we follow these same steps for the second one then?
Yeah, let's try it.
So should we solve for the bottom one?
Yeah.
Okay, so we want x by itself, right?
Yeah.
So if we subtract y squared over 32 to the other side, right?
Yeah.
Then we get 32 over 32. So I just change it to 1, right?
Yeah.
Minus y squared over 32. Then we get
18 minus 18y squared over 32.
say that again.
18 minus 18y squared over 32. Nope. I lied. I'm doing that a lot lately.
You just have to keep it like that. Or maybe if we just keep it as 1, so 1 minus y squared over 32, and then multiply the 18 over. Then we get x squared equals 18 minus 18y squared over 32, which reduces down to
9/16.
So 9y squared over 16.
And then to
and then you take the square root of both sides, right?
I think we need to get rid of the fraction, and then I think it'll be easier to take the square root. Right?
Oh, so you're saying, or
So right now, like, never mind. If you did that, then you have to do both sides, and then it would just go back. But 18 is not a good square root.
yeah, gosh dang it. Why is this one so difficult than the other ones?
Oh! What if, because 18 is 9 times 2, and then you can take the square root of 9, so that would be 3 square root 2. Right? And then
3 square root 2 minus 3 over 4, right?
Yeah.
Okay, maybe that'll work. Let's try that. So then we have to plug this x in for the first equation, right?
Mm-hmm.
Okay, so then we get all this. So 3 square root of 2 minus 3y over 4, all in parentheses, right? Or squared.
Yeah.
Plus y squared equals 25, right?
Yes.
And then we just solve for, or we solve the parentheses first, right?
Yes.
So then, so wouldn't it just be the 18 minus 9y squared over 16? If we squared each part of it individually.
Yeah. Why is this so hard?
I don't know. I'm gonna try.
I think I'm gonna send this to the TA and have her see if she can walk it through.
Okay.
Even if we get it, because maybe I think there has to be an easier way.
Yeah.
Don't you think?
This could be for sure. Y squared out.
Let me see if she answers.
16 minus 9 equals 7. Or no. So you get 7 times. Okay, I think I just got it. So this is what I did. So we're still at the 3 square root of 2 minus blah 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 squared, right? We plugged it into the first one.
Uh-huh.
What I did, so I simplified that back to 18 minus y, 9y squared over 16.
Okay.
Plus y squared over equals 25. So I subtracted the 18 over. So then what it comes down to is negative 9y squared over 16 plus y squared equals 7. You follow that?
Yeah.
And then I pulled a y squared out of the left side. So then I'm left with y squared, parentheses, negative 9 over 16 plus 1, parentheses, equals 7, right?
Okay.
So then I simplified the fraction on the inside. So then I was left with y squared, parentheses, 7 over 16, parentheses, equals 7. Right?
Yes.
Okay, and then I divided 7 over 16 to both sides. So then I was left with y squared equals 16 because it reciprocates when you divide the fraction.
Okay.
So it's 7 times 16 over 7. So the 7's canceled out. So I was just left with 16.
Okay.
And then I'm left with y squared equals 16. And then took the square root of both those. So I got y equals plus or minus 4.
Okay.
So then we have the 4. So one
If
of
you
them.
plug it back into the first one, you get the plus or minus 3.
Okay. So the first one's plus or minus 3. And then the other one we have to plug it in as well. So then let's see here. So if we do x squared over 18 plus 4 squared over 32 equals 1. So you get x squared over 18 plus 16 over 32, which is 1/2, right? Equals 1. So if you multiply or subtract 1/2 to both sides, you get x squared over 18 equals 1/2. Multiply the 18 to both sides. So then you're left with x squared equals 9, and then square root of 9 and x squared comes out to be plus or minus 3 again. So for the solutions, where you get plus or minus 3 and 4, and then plus or minus 3 again, and then negative 4. And that's what the answers come out to be.
Nice. You're awesome.
Man,
You earned that one.
that was ridiculous. I don't know why.
You?
Yeah, no, thank you. I mean, you helped with when we broke it down to 3 squared or square root of 2. That's where that helped. So when we got it down to x, and then we just plugged it back in, and then it gave us the original 18 minus 9y squared over 16 again, and then just went from there.
That's awesome. That one was hard.
Yeah, that one was dumb. Stupid.
Okay, I think that was the last one, right?
Yeah,
Oh,
that'll work.
I'll just submit this one in. Is that okay?
Yeah.
And then still on for Thursday.
Yeah, Thursday will be good. I don't know where Matt's at, so
Yeah, I haven't seen him for a while.
maybe
That one kid
work
for
or something still. Yeah. So.
Okay.
Okay, cool.
Stop